Hello guys. So this is a problem which is an extension of remove adjacent duplicates, which is an easy question. So if you did not watch that video, please do watch. I'll leave the link for that problem below in the in the description. So it should be pretty much similar to that question. We instead of calculating the duplicates, which is count is which count whose count is 2, we'll just take a generic character which is k and just implement that so that it will work for every value or every possible iteration of duplicates. So let's say we'll just go through the similar approach. We'll just have a string builder just because the string is mutable, and we will similarly take a stack, and what we will do, we'll just iterate through the string builder. And so the process is same, guys. So everything is gonna be same. If our initial character is 0 or the adjacent characters are not same, we are going to push 1 and minus 1. We'll just push 1 into our stack. And in the else case, here comes the logic. So what we will do in the else case, previously what we have done is the same thing. We'll just pop the top element and increment that whenever we find a duplicate. And then what we need to do is we will check if our increment is equal to k. Instead of checking that if our increment is 2, since we need to remove only duplicate values, adjacent duplicate values, we in the first easy question we just compared it with 2, and if you have a value of 2, you'll just remove that. Instead, what we are doing here is we'll just compare that with k, and if we have our k count of duplicates, we'll just remove that. It's the same again, guys. So as you see, delete will be to it will take values. The first index is inclusive and the second index is exclusive. So in our duplicates we did I minus 2 plus 1 and I plus 1. So here what we'll do, we'll have k duplicates, so we'll do I minus k plus 1 comma I plus 1, and here we'll do I minus k. So there's one more additional step, because let's say that we did not reach our k. So what we need to do is we need to push our current increment to the stack. Previously it's just 2 elements which are going to be repeated, so we don't need to take care of this situation. But right now we might have, our k might be 3 or 4. So when it is 3 or 4, let's say that we are at the second duplicate element, so increment will only be 2, so this case won't be there. So what we need to do, we'll just push that count into the stack and continue the process. So yeah, there you go, guys. So let me just go through an example why we use this condition. So let's say that, let's take the second example, the bigger one. So in this case, what we are going to do, when we get D, let's take a count stack. When we get a D, since our I is 0, what we will do, I is equal to 0, what we will do, we'll just push 1, and then our I will be 1, so our current character is E. Since they are not equal, we'll just push 1 again. Now our I will be 2, and notice that here k is 3, so k is equal to 3. So now our I will be 2, which means E again. So here we have a duplicate, E and minus E, sorry, E and E are equal. So what we'll do, we'll just pop this, increment is equal to count dot pop plus 1, which is 2. And now we'll check this condition if our increment is equal to k. Is that equal to k? No. So what we need to do, if it is equal, what we will do, we'll just remove that adjacent duplicates and continue with our process. But what if it is not equal? So that is where this condition comes into play. You have to push that count into the stack, which means I'm pushing 2 again into the stack. Now our I will be 3, which means I is 3. Now E and E are equal again. So what we will do, we will just pop the count and then increment it, which means 3. So now what we will do is we'll check whether our increment is equal to 3. Yes, it is equal. So what we'll do, we'll perform the delete operation. So let's say sp dot delete of what we will have here, I minus k plus 1, which means 3 minus 3 plus 1, which is 1, and then I plus 1, which means 4. So if you take the indices here, 0 is this and 1 is this. So 1 is inclusive and 4 will be D, which is exclusive. So you'll be getting a string which is D, D, B, B, C, 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 B, D, A, A. So this will be the string. You'll remove the, the first 3 elements and then continue the process. So in both of these questions, the time complexity will be O of n. O of n, because it's just the, you're iterating through the string once. So it will be O of n, and your space complexity will also be O of 1. Space complexity will also be O of n, because in the worst case, you will store ones, all ones, 1 1 for every character in the string. So it's going to be O of n in the worst case. Yeah, but in the normal cases, it should be constant. Thanks guys, please like and subscribe if you like this, and leave if you have any questions in the comments and we can discuss. Thanks.